Hi class. This video lesson goes with homeworks 26 and 27. So everything in this section is going to focus on factoring trinomials. I should say like 90% of the time. Trinomials meaning 3-termed, and these are going to be degree 2 for the most part. These are called quadratics, and we're going to focus on ones where the leading coefficient is 1. So there's a 1 in front of the x squared. Otherwise, we'll talk about GCFs and do that kind of specific situation. So that'll be the focus. So to motivate how this is going to work, we're going to start by doing multiplication. So multiplying out, you can use foil or grid, whatever works for you, drawing arrows. So in this case, we have x squared plus 5x plus 3x plus 15. So x squared plus 8x plus 15. So this polynomial, the one with factors of x plus 3 and x plus 8, turns out to be x squared plus 8x plus 15. So it's not a coincidence. The 8 in the middle comes from 3 plus 5, and the 15 on the end comes from 3 times 5. Let's do out this one. X squared plus 5x minus 3x minus 15. So we get x squared plus 2x minus 15. We have a minus on the end, this negative 15, because that's a negative 3 times a positive 5. So this one ends in a negative where the previous one ended in a positive. But the middle still comes from that 5 minus 3, looking at what happens when you put those two numbers together. Here we're going to get x squared minus 5x plus 3x minus 15, x squared minus 2x minus 15. So it looks really similar to that one, but the sign in the middle is different. I like to think that when the bigger number is negative, that middle number is negative. That helps me to remember, because when I do negative 5 plus 3, I'm getting a negative 2. So that bigger number being positive made the middle number positive, or the bigger number 5 being negative made the middle number negative. And the last one down here, x squared minus 5x minus 3x. Negative times negative is positive, so we get a positive 15. So this one looks very similar to the first one, except the negative 3 plus the negative 5 made it a negative 8, so they differ in the middle. So this is going to be the pattern we're going to look for. I'm always going to focus first on that last number. If the last number is positive, they had to have the same sign, because a negative times a negative is positive, and a positive times a positive is positive. If that last term is negative, they came from factors with different signs. One was positive and one was negative. And then next I'll look at the middle to figure out whether they should be positive or negative. So here is an example. Up here are instructions. Sometimes formulas are helpful for people, sometimes they're not. But let's start with a situation where everything in sight is positive. If you look back to the example we did before, when all of the terms were positive, our factors were both positive. So we're looking for factors that are positive numbers here. Now, what happened again? The middle, these two numbers here, whatever they are, they need to add to 7, and they need to multiply to 12. So I'm looking for two numbers that add to 7 but are going to multiply to 12. So I'm going to write over here underneath multiply to 12 all the different factors of 12. So 12 can be 1 times 12, but when I add 1 and 12, I get 13. So they didn't add to 7, so that's not right. 12 is also 2 times 6. But when I add 2 and 6 together, I get 8, which is not 7, so it's not what I wanted. 3 times 4 is 12, and 3 plus 4 is 7. And so, sort of like Jeopardy, we found the match that we were looking for. So x squared plus 7x plus 12 turns out to be x plus 3 times x plus 4. And you can FOIL this out and check and make sure that works. So over here in this case, I want it to add to 8, and I want it to multiply to 12. And you can see actually over in our table we did before that the numbers that multiply to 12 and add to 8 are actually 2 and 6. Typically when we're in class, someone asks me, does it matter which order? And it really doesn't. If you write x plus 6 times x plus 2, that is the same thing. So the order in which you write the two factors doesn't matter. What if the last number is positive, but the middle number is negative? If you, again, you remember our examples from the beginning, in order for that last number to be positive, that tells you they have to be the same sign. So that last number positive says they have to be the same sign. So if the middle is negative, these have to be two negative factors. So that's what we are looking for. So in this case, I'm looking for two negatives. And they have to have the property that they multiply to 30 and they add to negative 17. So I'm looking for two numbers that multiply to 30 but add to negative 17. So I have negative 1 and negative 30, which is negative 31 when I add them, not the pair I was looking for. 30 divided by negative 2 is negative 15. So negative 2 and negative 15 is negative 17. And that's the one we wanted. So it turns out that's x minus 2 times x minus 15. Over here, we want them to multiply to 30 and add to negative 11. Add to negative 11. And again, we're looking for an x minus and an x minus because two negatives are going to give us a positive 30. I've already tried 1 and 30 and 2 and 15 over on the left. So I'm going to start with dividing 30 by negative 3 and I get negative 10. When I add those, I get negative 13. So that isn't the pair I was looking for. When I divide by negative 4, I actually get a decimal, so negative 4 isn't going to be one of my factors. Divide 30 by negative 5, and I get negative 6, and that gives me negative 11 when I add them. So the factors I was looking for are x minus 5 and x minus 6. If we do minus on the end, the negative on the end tells you they are going to be different signs. And the negative in the middle here tells you that the bigger number is going to be the one that has the negative. So negative on the end tells you you have different signs, and the negative in the middle tells you that the bigger number is going to be negative. So down here I have x plus and x minus. I know one's positive and one's negative because of that negative right there. And because the 8 is negative, I'm going to put the bigger number here. So that's how I set it up. And again, I'm looking for things that multiply to negative 48 and add to negative 8. So that's what we're looking for. So I could have 1 and negative 48. When I add those, I get negative 47. So that's not what I wanted. 48 divided by 2 is negative 24. I get negative 22 when I add them. Negative 48 divided by 3 is negative 16. 3 plus negative 16 is negative 13. We're getting closer to 8, but we don't see 8 yet. 48 divided by 4 is negative 12. Negative 8, that's what we wanted. So we have x plus 4 and x minus 12. So that's how that one factors. Here, same thing, a negative 48, so one's plus and one's minus. A negative in the middle tells me to put the bigger number in the negative spot. I don't have negative 2 yet in my table, so I'll continue on after 4. I'm looking for negative 48 for the multiply, and we're looking for the add here to get negative 2. 5 doesn't go in nicely. We have 6 and negative 8, 48 divided by 6, and we get the negative 2. So this is x plus 6 and x minus 8. Last example, the end is negative, so that tells us one of each, but the middle is positive, meaning the bigger number has to go in that positive spot. So again, this is negative on the end, so I have to have one of each. Negative on the end, so I have to have one of each. The middle is positive, so I'm going to put the big number in the positive slot in each one of these cases. So I'm looking for things that multiply to 18, negative 18, and then I want to know what do I get when I add those things. So I could have negative 1 and 18. Remember, I'm letting the bigger number be positive. That's why it's what's positive in my table. Negative 1 plus 18, 17. Not what we're looking for. 18 divided by 2 is 9. Negative 2 plus 9 is 7. So that's the pair we were looking for over here. 9 and 2. X plus 9 times x minus 2. We need to keep going over here because we need to somehow get a 3. Negative 3 and 6. That gives us a 3. So 6 and 3. So notice I gave you examples where they both end in 18, but we have different numbers that we have to combine. There is a chance that there is a GCF that you have to deal with first. So in this case, I can take a 3 out of every term. 18 divided by 3, 15 divided by 3. So I first have to deal with the GCF. So it's possible that you'll have that kind of situation. Now both are positive. That means both factors I'm looking for are positive. Keep the 3 out in front. I am looking for things that multiply to 5 and add to 6. 1 and 5 are the only way I'm multiplying to get 5, and thankfully they add to get 6. So 3 in front times x plus 1 times x plus 5. Last one with a GCF. I can take a 2 out of everything. Everything's divisible by 2. And then this has a square, and they all contain more than that. So 2x squared is your GCF. I'm left with x squared. 14 divided by 2 is 7. And 36 divided by 2 is 18. The 18 is negative, so I have one of each. The 7 is negative, so I know my big number is going to go there. I'm looking for things that multiply to negative 18, but add to -7. So I'm going to get, let's see, the bigger number has to be negative. So -18 and 1 gives us -17. 18 divided by 2 is 9. -9 and 2, that's the one we're looking for. And so that's your GCF factor. So again, those last few were more complicated. You first had to do the GCF and then do the process. The most important thing is to look at those foiling problems we did at the very beginning that motivate everything else we did throughout the section. There's lots of practice on the worksheet.